Hi everyone, this is EasyPeps and welcome to another Houdini tutorial. I was working on my HDA tool to generate Lego bricks inside Houdini, and I decided to make a little video on the creation of this particular set, which are the plates without corner, because they are pretty simple to create, but they require a couple of procedural technique to take care of the variation they have. So if you already know your way around Houdini and you know how to work with procedural modeling, maybe this video it isn't for you because it doesn't have any complex technique inside it. But if you're a beginner of Houdini, you opened the software a couple of times, maybe you know how to lay down some node, then you can easily follow this tutorial and you will see the node or procedure we commonly use in procedural modeling, as well as some technique like the switch or if condition to take care of any possible variation you have in your different models. So as you can see, I already have some geometry in my viewport, but these are not the piece we're going to create. These are the reference I use to create the piece inside Houdini. And since you're following the tutorial, you don't need to have the reference as well. But if you want to create it as well, you have a couple of ways to do it. Either you go on the Eldro website, where all the part library is, and you look for the pieces, you find the piece you want to import, you need to download it. They will be downloaded as Eldro format, which you have to open with this other software, which is LDView. Here you can export it as STL file, which is the only readable format between the ones available in LDView. Or a faster way is to download this other software. It's called LeoCAD and it's totally free. It has a good library of parts, so we can look for the ones we want. So let's write without corner. And here you just need to lay down the parts you want to export. So let's say this one. And you can export it as wavefront OBJ file, which is more digestible by Houdini. And this is the way I use to create my reference here. Now, as you can see, if I scrub on the timeline with the left and right arrow, I'm cycling through the different variation of the pieces. To create something like that, you just lay down a file node and import the model we exported from LeoCAD. Right away it is flipped because LeoCAD uses different axes, so let's lay down a transform node and rotate it on the x-axis by -90. Now, before doing the for each stuff, let's just talk about the alignment, and we want to quickly select just one pieces for the moment, hit the delete key to create a blast node, and reverse it by checking the delete node selected. So let's pretend we have a single pieces and we want to align on the origin. In Houdini you have multiple ways to do it, and the way we're going to do it is with a transform node and with a simple expression on the translate channel. If you open the Houdini help and type expression cookbook, we have this page where all the expressions available in Houdini are listed, and right at the beginning we have this stuff, which is centroid, sides, corners. These are usually the one you use to control the alignment of an object. In the specific, we are going to use this CX expression. If you know a little bit of Vex, you may recognize you have the equivalent here if you want to use it inside a wrangle node. But we're going to use the HScript version because we want to use it directly inside a transform node. And if you want to put an expression here, either you use the HScript or you go with Python. So let's plug the blast node to the transform, and we want to type into the X channel $CX. As you can see, our geometry has been moved, even if in the wrong direction. But let's press space and 2 to go in the top view. So if we display the blast node, we can see that the center of the geometry is basically lying on -80 in the x-axis. After we use the expression, has been moved to 160. And that's because this expression basically looks for the center of the bounding box on that axis. Let's hover on the blast node and click on the eye icon. We can bring up this information about the current node, and as you can see here it says center. We have 3 values. So basically this $CX is taking this minus 80 and is adding to the current position, which is already minus 80, so the geometry has been moved on minus 160. So if we want to put the geometry on the origin, we just need to reverse this expression with a negative sign before it, and now is adding 80 to negative 80, so we are back at 0. And we want to do the same for the z-axis, so $CZ. If you put x also in this channel, it will take that negative 80 again. And now we align the geometry on the origin of the axis. The thing is, we need to do it for multiple geometry, and of course we can just bypass the blast node, otherwise the expression will use the bounding box counting every geometry, so it's basically aligned on the center of the whole selection. And that's the reason we are going to use a for each node. If you press tab and type for, you will see multiple types of for each loop. It depends on the object you want to iterate, and we want to use this for each name primitive, which basically look for the name attribute inside your geometry. Now let's display the transform mode and click on the eye icon again. So you can see that we do have one primitive attribute, is this shop material path, and then we have the normal and position attribute for the points. Currently we don't have any name attribute, so this loop won't find any geometry. But we do see that from LeoCAD, by default, each piece comes with a different group, and we can use this grouping layout to actually create a name attribute. We do it with this name SOP, and we can use this name from group, which is basically the same as the regular name, but it's already set in a way that will take the group and convert each group to a name attribute. So let's plug it after the transform node. And if we go on the geometry spreadsheet, we can see that this node has actually created a name attribute, but it's empty. That's because the group mask look for a piece, and this symbol means everything, so it looks for every group named piece something, but the P, as you can see, is not capital, where on the transform node our group naming has the first letter capital, so let's just put a capital P up front, and you can see that now we have a name attribute, and it's different for each piece. So now we want to plug the name node into for each, and we want to move the transform node with the expression inside the for each loop. So if we display the for each end, you can see that we have all the geometry aligned on the center of the axis. Now, of course, they are still a single geometry, so they are sitting on each other. And to display the separate geometry, we can enable this single pass option. Basically, here you can cycle through the different for loop iteration, and we can use the @frame expression. So now the number here will be the current frame, and by scrubbing the timeline, we cycle through the different pieces. Currently, we are missing the 0 pass because our timeline starts from 1, so either you change the timeline to start from 0, or we can simply add a -1 here. So now we're starting from past 0, and we are cycling through the different pieces. Now, as you may notice, here I used an @ sign, not a $sign. That means I'm using vex directly inside a parameter channel. If you open the page from before, where we looked for the CEX expression, you can read here that Houdini will move toward using more vex than HScript because vex is much faster. That means you can use some vex equivalent in the parameter channel. Not everything is still supported. Let's say if you are not sure of the vex equivalent, if you are not sure it will work, you can go easy with the HScript, which is totally supported yet. So now we have our reference. I can delete this other copy, and we can start to create the geometry. So let's go back to OBJ level and create a geonode and dive inside. Now we want to go on the Hide Other Object button and say Ghost Other Object so we can partially see our reference. Now, if we go back to LeoCAD and look at our geometry, we can see that pretty much it's just a matter of sides, except for the 6x6 and the 10x10, which have the double amount of space before the corner start. Here you can see there's a one row and then start the corner. Here we have two rows. Except for that, we have a different layout on the 10x10 for the top stud. Then we have a different number of this kind of hole in the corner side based on the size of the piece, and a different layout for the bottom stud also. So let's go back into Houdini, and first we want to take care of the main shape. Now, before doing it, we want to build our controls, and in this case we just need one because the pieces are all square, so we don't need like a length and width channel, we just need the sides for it. And we want to drop down a null and call it control. Now, if your intention is to create an HDA, you can go with this method, or you can create the parameter directly on the HDA, so you can link those parameters to the geometry we are going to build. But this tutorial is not about building an HDA, we are not going to do it. If you want to know how to do it, you can go check my other tutorial, Lego Brick Generator in Houdini. And let's go on edit parameter interface. We can select these two parameters and set to invisible because we don't need those. And we want an integer slider because they are all pieces. So let's say we can call it corner sides. This name is the one used in the expression for Houdini, and the label is the one you see in the interface. So don't use space here, I don't think it's even allowed. If you type space, it will put an underscore. And I encourage you to keep all lowercase for convenience. Here in the label, we can use capital letter, we can use space because it's just a label. So we can call it corner sides. And we know that our pieces will go from 2 to 10. So we can already set the slider for it by enabling the range from 2 to 10, and we can lock with this button. Basically, let's apply it for a second. You can see that we have the lock on the 2 and not on the 10. So the slider are actually from 2 to 10, but on the 2 we have the lock, so you can't even go lower with the mouse wheel. Instead, on the 10 we didn't put the lock, so with the mouse wheel we can go over the value. So let's put a lock because we know that our pieces will never exceed 10. So let's apply and accept. And we have our controller. And of course, our slider goes from 2 to 10, including all numbers. Even if we don't have the 5x5, 7x7, and 9x9, I believe, I don't think they are existent or included in the library. We don't care because we may want to generate it anyway or not. But it's not a problem to have also that variation in the library. So let's lay down a grid to start with our piece. And depending on the scale you want to model the whole thing, it may change the size of Houdini unit compared to Lego unit. If you exported from LeoCAD and you didn't touch the scale in the reference, you will have an equivalent of one Lego unit will be equal to 20 Houdini units. So if we move the grid, you can see that basically 20 Houdini unit is just one Lego brick. Now don't take the 6x6 as first reference because as that size variation. Let's move to frame 3. So we have the 4x4, which is one of the most common. Let's put the rows and columns of the grid to 2. And for the sides, we say that one Lego unit is equal to 20 Houdini unit, and we are deciding the sides here. So basically this 4x4 will be this slider multiplied by one Lego unit. So we can right click on the corner sides, copy the parameter, and here we can type multiply and paste the relative reference with right click. And here we can do the same, or you can even copy this parameter to this, because it will be always a square. So now we already have our controller working, because we are deciding the piece size with the slider. And so we can set it to the 4 as the current reference, and let's move on. Now we can make the cut on the corner, and let's switch to the top view. If we scrub through the pieces, since we centered all of them on the origin, you can see that the location for the cut, it's always the same except for the 6x6 and 10x10. So we want to lay down a clip node, and let's see, we are on the 4x4, and we want to orient the cut in the XZ axis in a diagonal way. So we want to change the direction to 1, 0, 1. So we do have the cut, it's in the wrong way, so we can change this keep parameter to the other side of the cutting plane. And now we want to change the cut location, so we want to increase the X value until 20. So now we do have our cut, but we need to take care of the variation for the 6x6, which you can see that as the cut more towards the x-axis, and also for the 10x10, because it does the same layout. And the way we are going to fix these variations is by using this origin x value within a if condition. So basically we are going to state that if this corner size will be equal to 6 or 10, this value will be used, and otherwise it will be used the other value, 20. So this is the if expression function relative to hscript. As you can see, it's if, and between the parentheses you have the condition you want to evaluate, the result when the condition is true, and the result when the condition is false. And in our case, we want to evaluate multiple conditions, because we want this value to be changed both at 6 and at 10. And the way you concatenate multiple conditions, you use the classic programming operator like the AND or the OR operator. And the way they work, when you use the AND operator, basically you want both conditions to be true to have the true output. If you use the OR, you just need one of those conditions to be true to have the true output. So in our case, we want to say if, and we want to grab this parameter, so copy parameter on the corner side, we want to paste it here. So paste relative reference, when this corner size will be equal to 6, or when this corner size, let's quickly copy it, will be equal to 10, then comma, so this is basically the expression value. Then when this will be true, so to 6 and 10, we want to use 40 as the clip origin, otherwise we will use 20. So now we have just one row, but on the 6 and on the 10 variation, we have the double of the space. If you click here on the parameter name, you see the output and not the expression, and you can see that, let me pin it for a second. You can see that on 10 and 6 is 40, and on the other values is taking 20. So now let me close this parameter window with the P key, and let's unpin this window here. If you pin it, basically you can switch between all nodes, but you always have the parameter for the nodes you pin. It's very useful if you have an HDA and you want to maintain the visualization of that parameters maybe in a separate window. So now let's add some depth to the pieces with an extrude, a poly extrude, and the depth will be always the same height, which is 8 for the scale I'm working to. So basically we don't need to do nothing on the extrusion itself, but we want to enable the back and also enable the back group. Let's call it bot for bottom. So now we can do the inset part without manually selecting our polygons. So let's grab another poly extrude, and we want this extrusion to be active only on the bot group. So if we increase the inset and we put the correct value on 4, we already have our extrusion, and now we just want to grab this node with Alt pressed and we can duplicate it. So it's already set on the bot group, and this time we don't want to make an inset, we want to make an extrusion of -4. One thing you may have noticed, I didn't on the first inset activate the back group to have the new poly group, and that's because it's not needed. We are acting on the bot group and we are editing that group. So if you have an extrusion to make on the same group, you don't need to activate the group every time, you don't need to give it different name, you just need to have the same naming on the following extrusion. So we have our inset and it's working within the controller. So basically we take care of the main body. Now we want to check these corner holes. Now to make the holes, let's go outside and hide the geometry so we look at the reference. Basically the idea is to scatter some boxes along this diagonal line and subtract the geometry from the piece with a boolean node. And if you watch closely, you can see that the last hole on both sides of the pieces are corresponding to the last row of stud, and that means there's a pattern going on. Basically, if we go in the geometry, lay down a grid, and also for convenience let's press Alt and the square bracket key, the right square bracket, so I can select this control, switch this with the right click to parameters, and we have it unpin and pin again, so we have the control over here, and this bottom one will be the one with the other parameters, so we have this one always visible for convenience. Now let's go back on frame 3 so we see the 4x4 reference. Let's decrease the rows and column of the new grid to 2x2 for the moment, and let's see, if we increase the sides, we notice that we match the correct location of the holes we want to scatter when we are at 60. Right now on the main geometry we have a 4x4 as you can see from the corner sides, and the sides of the grid is 80. That means that this grid is basically the same expression we have here, so we can copy this 20 unit by the corner sides, we can paste it here and quickly copy this parameter and paste it on this other one, always a square grid. And what we want to do is to not use the corner sides, but the corner sides -1. So now we do have that 60, and you can see that by decreasing the corner sides, of course the reference is always the same, but let's say we have the 8x8, we still have the correct hole location. Now the problem is we only have the outermost point for the scattering of the box. We need to generate also this other one, and right now we have corner sides of 8. So basically if we increase the rows and columns on 8, we generate the points in the correct location. And let's switch on the 4x4 reference. If we set the corner size to 4 and also the rows and columns to 4, we still have the points on the correct location. So basically this parameter can be the corner size. So let's copy parameter and paste it here. Now the only thing we still have to do is to isolate only the point on this diagonal line. To do it, let's take a group node, and we don't want to use the base group, we want to use a bounding box. Now we could use this box, but the problem is you can't rotate it, and we need to be oriented on 45 degrees, so we can't use a bounding box here. We need to use a bounding object, which goes in the second input. So let's create a box, and a regular one will be fine. We want to use a transform after it, and let's plug it to the group. Now we want this box to be oriented on 45 degrees, so it matches the diagonal. and we want to be very safe that it includes all the possible pieces, so let's put the X scale to something like 500. And now we need it moved basically where the slice of the pieces occur. So basically we can take this origin value. So let's copy the parameters here on the origin and paste it on the, let's see, on the Y translate. And now it seems wrong, but it's actually accounting for the 6x6, so it's actually correct. And this warning is because we didn't specify the group type here. It says primitive, but we're using a bounding object which says only points or vertices. So let's switch the group type to points. Now we don't have the error, and we can see the points in yellow which are in the group. And we still have the correct diagonal of points selected. Now we want to scatter our boxes on this point, so let's take a box node and a copy to points. Let's plug the box on the left and the group node on the right. And here right now is copying on each point because we need to specify the target point group, which is this group 1, which of course you can rename it for convenience. Let's call it copy, and also here let's change it to copy. So now we do have the geometry generated only on the correct points. We don't care about this outer one because the geometry will never touch those points. So now we need to take care of the orientation and size of the boxes. And we know we want the box rotated on 45 degrees on the y-axis. And as you can see, is rotating it wrong. Let me increase the size for a second. Ideally, it should rotate this way, as you can see from the action button here, but it's rotating in the wrong way because we didn't specify on the source point any normal or up attribute. So let's take a point wrangle, and here we can say that the normal value, so at n, will be equal to the z-axis, so 0, 0, 1, and the up attribute will be equal to the y value, positive, so 0, 1, 0. And go back to the point. Now with the 45-degree rotation on the y-axis, it actually rotates in the correct way. So for the size, let's increase until we have the correct value, which seems to be 12. On the y size, we know we have the half of the value of a brick, which was 8, so 8 also here because it starts from the 0 coordinate. And as for the z value, just make sure that we take all the border. So now if we take a boolean, let's plug the main shape on the left and the copy to points to the right. Let's hide the reference for a second, and we already have the correct result. Let's change the corner size. So it basically works, but I don't like the topology the boolean is generating because that may cause a lot of artifacts. So what I like to do is to prepare the geometry with some cutting corresponding where the border of each box is going to be, so the boolean will happen on the already existing points. Basically, we want to use the same copy to points we created for the boxes. Let's copy over here. And instead of scattering boxes, we want to scatter two grids which will act as cutting plane. So let's take a grid. We want this to be 2 by 2 in rows and columns. Now we want this grid to cut where the boxes are, so let's put the template flag on the box. And we want the grid oriented on the XY plane and translated 6 units because the box was 12. And now we can mirror it on the other side, so on the negative z, which means here, and let's rotate it for the 45 degree on the y-axis, or rather negative 45 degree. So now if we replace the input on the copy to points, let's put the template flag over here. Let's see with the reference. We are generating the cutting planes. Of course, we need this to be very big. So let's say 1000 by 1000. And now we want to make another boolean before this. So let's take a boolean, plug the main shape and the cutting planes. And here we don't want to use a subtract operation, we want to use a shutter one. And to avoid the generation of inner polygons, like you can see is happening here, we need to switch the 3 test surface for everything. So now it's basically just some cutting planes on a geometry. Now, before plugging the boolean inside the second one, if we enable the point number, you can see that the boolean has cutted the geometry correctly, but has generated some duplication on the points. So just fix the geometry by using a fuse node, and now we have a correct cut geometry. So let's replace it for the second boolean. And of course here we need to use the other copy to points, the one with the boxes. So let's hide the point number, hide the reference. So as you can see here, the cut is correct. And now what we want to do is to put the template flag on the boxes and try to match also the Z sides. Ideally it will be 8, but it may cause some issue here where you have a perfect match. So I would put this to 8.1. It will be a slightly bigger and it will not cause artifact. So after the boolean we can plug a second fuse node that will merge this point. Let's remove the template flag and let's find the correct value. 0.1 is fine, so now we're also fusing the points. Now the last thing I don't really like about this topology is this n-gon over here. So let's just take a knife. After the first fuse, we want to set the knife to be, let's see, the direction is good. We want to be on the y-axis, but we need to raise it on the half of the brick sides, so 4. So now we do actually have a clean topology for our pieces. So basically we have the main body ready, and we didn't need to take care of the 6 and 10 variation, because the only thing we actually change is this translate value, which is tied to this clip node. As you remember, we put our condition here, so everything is updating accordingly to the expression we set. Now we need to create the top and the bottom stand. So for the top one, let's drop down a circle and let's rotate it on 180 on the x-axis. And we want this to be oriented on the ZX plane. Let's increase the division to, let's say, 48. And the scale of the stud, according to the scale I'm working to, it needs to be 6 units. As you can see, going in the top view is the exact size of the original studs. Now we want to use a polyextrude node. And the distance of the stud, meaning the height, it will always be 4. And we don't want the front or the back within the output, but we want to enable this front boundary group, which is the one you see in grid, and we can call it bevel. So later when we will decide the bevel, we already have the correct group on the studs. And after it, let's take a polyfill, and we want the fill exactly that group bevel with triangle fan, and turn off the deform patch. So we have a closed stud. And now we can copy to points this geometry. And similarly as we did for the boxes, we want to scatter this geometry on a grid. And for this tutorial, we can easily plug this input right on the copy to points. But if your plan is to do an HDA where maybe you use this geometry a lot. My suggestion is to take the habit of renaming these things with a null. So let's say out top stud. So you can have it in a separate place. So later on you can take an object merge whenever you need this particular part, and you can just drag and drop it on the object1 field, or you can even type it. So you don't have to recreate this geometry for every different set you need. Now to scatter the pieces, let's take another grid, and right now we are seeing the 6x6 variant. So let's see, put the columns to 2 and 2 and increase the sides until we match it, and it's 120, which is the same size of the body grid. So basically the sides, we can use the same expression here. So let's copy it on the new grid, and let's also copy this parameter to this other one. And now if we increase the rows and columns, let's say to 7 and 7, we can see that for each polygon of our grid at the center we have the correct location for the stud to be generated. And if it's 7 when the corner size is 6, let's say we want to generate it on the 4 variant, it should be 5, and it is, meaning the rows and column can be these corner sides. So copy parameter, paste relative reference +1, and same thing for the columns. The problem is, if we plug the grid right now, the studs will be copied to the original points on the grid. We don't have the points on the middle yet. Now to generate those points, we want to use a primitive wrangle, so we can basically execute something on each polygon of this grid, and in this case we want to create a point at the center of each polygon and then delete the original points. We can use two functions to do that. The first is the add point, which basically generates a point on the geometry based on the input we gave the function, and the first input is the geo handle, meaning the incoming connection of the node. And we always start to count from 0, so being the first is 0, and then we want to use the position attribute, because the position attribute on a primitive is its center, so it will create the point exactly on the center of each polygon. Now we want to delete the original polygon, and we can use this other function, it's called remove prim, which asks for the same geo handle, the primitive number we want to delete, and here where it says endpoints, we input 0 if we want to delete just the polygon, or 1 if we want to delete also the point. So in our case it's 0, we want to delete the current primitive number, so it's add prim num, and 1 because we also want to delete the point, and semicolon at the end. So now we do have the points in the correct location. If we switch to the copy to points, they are where they should be. We can raise the grid to the exact height, which is the same for each pieces, so a set value is good. And now we need to delete the extra points, so we can use the clip like before. So let's take a clip node, and we want to clip on the 1, 0 and 1 axis, just like this other clip, and we can copy the origin of this one and paste it right here, so they match. But we also need to include the points on the corner, so we just need to increase this value a little bit until we take also the points, and we need to switch the direction. So now let's set it to -1, so it will include only the points on the corner, and let's switch on the copy to points, and we have the correct stud. Except on the 10 by 10 variation we miss this stud in the middle, so we need to take care of that, and we can simply do it with a blast node, because only the 10 by 10 will have this particular layout for the studs. So let's see, put the display flag on the copy to points, and here we want to delete points, and we want to take this one. So now we do have the correct value, but of course when we change it, this blast needs to go away, so we can use a switch for it. So let's plug the original clip on the first input and the blast one as the second, and replace the copy to points. And here, if the input of the switch is 0, it's taking the original clip. If it's 1, it's taking the second input. So we can write that if, let's take the corner sides, copy parameter. So if the corner sides past relative reference is different from 10, then take the first input, otherwise take the second input. So now we should have every stud except on the 10, which will switch to the blast node. So we're done with the top stud also. Now we want to do a similar thing for the bottom stud. Let's first merge the main body with the top stud. So far everything is correct. And now we can actually use the same grid we used to scatter the boxes to generate the bottom stud, because as you can see, we again have each polygon of the grid matching the center of each bottom stud. So let's duplicate this grid, and we want the same expression from here, so the add point and remove brief function. So now let's duplicate also the copy to points and the top stud for the time being. And if we go on the copy to points, you see that the location is correct. Of course, we still have the top stud geometry, so let's take care of that. We can duplicate the top stud network. Let's rename it to bottom stud, and rename it also in the object merge. So type B and select the correct geometry. So this time on the first extrusion, let's put the distance back to 0 and the inset to 2, and reverse the direction, putting the rotate X back to 0. And here should be -2, my mistake. So now we do match the width of that stud. And now we want to add another extrusion. And this time on the first extrude, let's also select the back boundary group and name it as bevel. So we do have a bevel either on the outside and on the inside, or if you don't want it on the inside, it's up to you. Just remove this group if you want. And on the second extrusion, we just want to transform the extrude front in a global way and raise it by 4. Here we want to disable the output front because we don't need it. We have the bottom of the main body, and we want to enable the back. Then we can remove the polyfill because we don't need it anymore. And if we go on the copy to points, we have the correct geometry, except we still need to clip it, and we can use the same clip from the top stud. And there we have it. So now we can merge also this copy to point on the merge node. Let's disable the point visualization. Let's hide the reference. And the only thing left to do is to establish a bevel group for the main body. So let's take a group node. We want to disable the base group, switch the group type to edge, and enable the include by edge. Here we can enable the min and max angle to pick the correct edge we want to bevel. Some value like this should be fine. And we don't need to do the same thing on the stud because we have the bevel group coming from the extrusion group. So after it, we can lay down a poly bevel, and we want to act on the bevel group. So if you increase the distance, let's say 1, and we didn't rename this group to bevel, so let's fix it. So now we do have also the bevel on all the pieces. And let's see how the variation are going. So yeah, everything seems working correctly. So I guess that's it for this tutorial. These are some basic procedures you use in a procedural modeling inside Houdini. or I believe any procedural environment. And of course you can add all kinds of control you want. Currently I'm working on this HDA tool, which has a pretty good amount of pieces available so far, and inside is very complex. So that's it for this video. Don't forget to like and subscribe to the channel if you enjoyed my content, and I'll see you in the next one.